Okay,
Ready?
let's rock.
Okay, I'm Jeff Mattocks with Allied Equipment. I'm talking today on expansion tanks. Basically, the purpose of an expansion tank in any hydronic system is to allow your pressure to increase to where you do not lift the relief offsetting in the system, whether it's chilled water, heating water. I have a lot of people call me, hey, my tank pressure went up 10 pounds. That's okay. Did you lift your relief valve? No, well, you're good. When you get it to full firing temperature, your pressure can swing from 12 pounds of fill pressure. You have a 125-pound ASME system. We size tanks to allow it to go up to about 5 pounds below relief valve setting. So your system can increase in pressure as the firing rate goes up and the heat increases from 40-degree fill temperature to 200-degree operating temperature. That pressure will go up and down based on the temperature.
So water does expand and contract.
Exactly. Water is non-compressible. So when it's in the system, it's expanding. And if we didn't have an expansion tank to give that extra expanded water somewhere to go, the pressure would just go through the roof. So, and you have relief valves set 150, 125, whatever. That's what we use for our maximum for your system. You tell us what your relief valve max is, which is related to the weakest link in your system. If you've got runoff panel radiators on that can't go over 56 pounds, we need to size that tank to not let it go over 50. If you've got fan coils and everything else that's rated for 200 pounds, now you're limited to your piping. That's probably 150 psi. So you might have a 150-pound relief valve when you size it to 125 pounds. So if you see your system start at 12 pounds and go to 110 pounds, it can do that. It's allowable.
So you're going to tell us how to size the tank?
I'm going through all of this. Going through all that. So
Probably a list of things you need.
oh, there's a bunch of stuff. So anyhow, this is your typical HVAC system. Your expansion tank always wants to go on the suction side of the pumps. Okay. The reason for that is you either have like this is a glycol system, you would have a glycol feed system set at whatever pressure you need that fills the loop, or you could have water, you just have that as a PRV. And that will be set to fill the loop of the building to the top of its height plus a pound or two to remove air at the top of the building. So it always goes at the suction of the pump. And the reason being that is that's the point of no pressure change. And my pumps are sized correctly. By the time they come on and run that loop, I've exhausted all that extra head that's been supplied by that pump. Because up and down is, we don't do any lifting with pumps. All we're doing is overcoming friction. So if I run out all the way and back, I've exhausted all the heads. So this pressure at the suction side will stay fairly constant. Whatever your fill pressure is, it'll only go up as the water expands. So that's why you want to put it there, because we put the expansion tank on the other side. My pumps are off, I have one pressure. Turn the pumps on, I'm going to see all that pump pressure before it can exhaust itself coming back to the beginning. So that's why it always has to go on the suction side of the pump as close as possible. And that's where your fill valve goes, you are separate. I'll tie in at the suction of the pumps, and that's the reason. It's the point of no pressure change.
And it's also important to maintain that pump suction positive pressure.
Well, but that's why you're always going to have, with a closed loop, you're going to have a glycol fill. For a PRV, you're always going to have at least 8 or 10, 12 pounds of pressure there. But if I have I'm going to get it in a second, 2.31 psi. 2.31 feet per psi. So if I have a 231-foot building, I need my PRV set at 100 pounds just to fill that loop, plus a pound or two, so I'm positive on the top loop ready. You know, that'll fill your loop, but your pumps don't have to pump that 100 psi. It's like, look, in the basement, it's 100 psi here, near the top, I'm at 2 pounds. And I come back down and back to 100 again. So it's equal. We don't have to lift anything. The pressure fill does
closed loop.
Correct, closed loop, not open. These are the different kinds of expansion tanks. One of the continentals is a plain steel tank. The drawbacks to those, and we're going to get into a little more depth, that's only filled by atmospheric pressure. These other 3 tanks, the CX series is a diaphragm tank. Then we have a full bladder tank, they call it. And we have a partial bladder expansion tank. We'll get into that a little more as we go on. These are some important equations. If you ever get out in the field and don't have any idea what an expansion tank is, if your fill pressure is under 20 psi, you can use this rule of thumb. You can take the BTU system divide by 15,000. That'll equate to the size of a plain steel expansion tank. If you take it times a factor of 0.55, that'll give you the volume of a full bladder expansion tank. Not a partial, it has to be the full bladder. You'll see that in a minute here. So if you ever get out in the field and have no idea what tank you need, this will keep you safe as long as your pressure is under 25. You start getting higher fill pressure, that's going to change. But 99% of what you're going to do, that'll cover you for just picking a tank size. Okay. Right here. First one, plain steel, their atmosphere. The big thing with the plain steel tank, you want to do these connections in the bottom. And I'll show you this in a second. The tank control gets connected there. One's the drain and one's for your tank control. Now they're incorporated into one. They always have a gauge glass on. The downfall of that tank is they only have 12 psi of atmosphere in when you fill them. So as soon as you put your fill pressure to it, that tank's going to flood till it compresses that air. You're going to lose about half of your tank. So that means that tank's got to be a heck of a lot bigger than a bladder type tank because we have only 12 psi in there. A diaphragm tank, it sounds just like it is. There's a diaphragm, like in your diaphragm in your body. Exactly how it works. Air's on one side of the diaphragm, water's on the other side. You pre-charge that tank. All bladder tanks, you pre-charge it to whatever your fill pressure is. The reason that is so when I put 12 psi of water on it, I have 12 pounds of air pushing back. The tank is absolutely empty when I start expanding. If I only have 8 pounds and put 20 pounds on it, I'm going to fill my tank up and lose expansion volume. They follow that? Understand? Most of the diaphragm tanks are throwaway tanks. They're cheap, but if you rupture that diaphragm, you have to buy a whole new tank. There's no way to replace that bladder. That bladder is fixed, and it's junk after it ruptures the bladder. Then you have the partial acceptance volume tanks and the full volume acceptance tanks. And we'll get into this. You'll see pictures of them. When this partial acceptance is a bag hanging in the tank, the water goes in the bag, the air pressure is around the tank. The full bladder, the bladder actually mirrors the entire size of the tank. So if you use that rule of thumb, you need to pick a full bladder tank because the partials, you have to figure out what your expanded volume is plus air charge. Or if I have the full tank, I can't blow that bladder up. Does that make any sense to everybody?
The entire bladder, the air is in the bladder.
No, the water's in the bladder.
Oh, the water's in.
But that bladder has to be big enough to take my expansion volume.
Right.
Where if I have a full bladder, I can fill that tank all totally full of water, not break the bladder. And we'll get into that a little more as we go along. But
Question on the expansion tank rule of thumb, that the total volume of full acceptance volume expansion tank, is that in cubic feet or?
gallons. Well, it's liters or gallons.
That's
Like it's like I'm a Tanko rep, but they all use liters. Like a CA 450, that's 450 liters. And that is the volume, full volume of the tank. Where if you get into the CBXs or the CXs, which are the diaphragm, you actually have to look up and say it'll hold 18 gallons of acceptance, but it's a 46-gallon tank. But my expanded volume can't be bigger than that bladder. And we'll get into that more as we go along here. You'll see, I've got pictures, and down at the bottom, it's talking about ASME code. In the state of Ohio, anything over 199,000 BTUs on a heating system requires an ASME coded tank. And it's all based on whether it's your system height, what your operating pressures are. Standards 125 PSI ASME. So we also offer 150 pound ASME, 250 and on up. But for the most part, 125 or 150 covers 95% of what you do. For Tanko, we don't make any non-coated tanks. People like Amtol, they make non-coated tanks. So if you're under 199,000 BTUs, you probably don't want to buy a tank from me because I have to sell you an ASME tank that you don't need. The difference in the tanks is identical. Even if you go to the Amtol tanks, a non-coated tank and a coated tank are absolutely identical. The only difference on ASME code, they're tested, there's an inspector on site, and every bit of material that went in that tank is followed from birth to death as it comes from the factory. They know where the steel came from, they know the inspection stamp, they can look up the serial number, they know everything about that tank, and the insurance underwriters like it because now I've got somebody saying this tank is not gonna fail. I've looked over their shoulder. Below 199,000 BTUs, you can buy that same tank, but that ASME coating costs a lot of money. So you could take, let's say, an ASME tank that's a 20-gallon tank might be $1,000. The non-ASME tank would be 300. That's that much difference in them because they have to track that paperwork for the life of the tank, you know, so there's a lot of money involved. You have to get the shop certified, you have to have an inspector you're paying to stand there and stamp all these, and you know, it looks like a little clover stamp with the U on it. And these are all stamped in ASME Section 8, which is for any pressure vessel. And they have to carry that over 195,000. You get an inspector come in and he doesn't see that ASME stamp on your tank and you're 800,000 BTU boiler, he'll red tag you, shut you down. In the same way it goes with air separators. Anything over 199,000, any pressure vessel, the air separator expansion tank has to be ASME coded. It's the law. That's for Ohio Revised Code. Okay, so just remember that number, 199,000. That's BTU input. Okay. Okay, here's your plain steel tank. So if you have a, yeah. This is your plain steel tank right here. And we talked about this earlier. Fill valve should be at the same location. Here's how you calculate your fill pressure. Like I said, 2.31 feet is 1 psi. So I have a 231 foot tall building. If I divide it by 2.31, that gives me 100 psi. This fill valve has to be set to 100 psi to fill that building up before I even turn on the pumps. Then I want to set it a pound or two higher to so positive pressure on the top loop. You have your air vents up there, little positive pressure. You open the air vent, you're going to get the air out, and the water is going to eventually make it to the top of the loop. Once you've accomplished that, all the pumps do after that is overcome the friction in the loop. That's all they're doing. Because whatever I filled, this is coming up, this is going down, it's all equal. You know, 100 psi here, and 2 psi here is 100 here, 100 here, 0 there. There's no differential in the loop sheet because it's all in equilibrium. Everybody follow that? But moving the water, now I'm causing friction in the pipes. That's what the pump is. Everybody understand that? Any questions? Going too fast, too slow?
Yeah, do all those thumb rolls and numbers change when you switch it over to glycol from water?
What's that?
Yes. Switch it over to glycol from water.
When we get into sizing here, you'll see there's a coefficient of expansion for the liquid. And that's based on whether it's water or it's glycol. And they do make a difference if you're sizing your tank. That rule of thumb I gave you, that's for water. Yeah, but everything changes when you go to glycol. But we'll move on here, you'll see what I'm talking about. Look. Right here, this is a plain steel tank. If you ever see a tank that's mounted way up in the ceiling with the sight glass on it, that's a plain steel tank. Which means it only has atmosphere pressure in it. So this tank has to be much larger than a bladder type tank. Here's a picture of one. You walk in, you see this right here. If the sight glass is full all the way, let's say you get a call and somebody says, "Oh, I'm blowing my relief valves. I don't know what's wrong with my system." First thing you're gonna do is look at the sight glass. If it's full, that means your tank is waterlogged. They should be running quarter to half full. Because when you first align this tank, as the 12 pounds of fill pressure comes in here, I'm compressing that atmospheric fill, and it's gonna,
That quarter to half full, that's at full normal system pressure at full normal temperature.
no, that's at fill pressure. As soon as you put 12 psi, I have 14 psi in here of atmosphere. But now I'm putting 12 pounds above that. So it's gonna compress the air.
Is the system hot or cold?
Cold iron. This will fill up about a third of the way, let's say. Then as you heat up, this tank will go higher and higher and higher. As it cools down, it'll drop back out, push. As the expanded water fills, it's just going to fill itself up. As it cools down, it's going to push it back into the system. But if this is totally flooded, and I'm a cold iron, I have nowhere for that expanded water to go. So then you start lifting your leaks, and your pressure just goes exponentially up through the roof. So if you run into one of these tankers, this is the tank control. This is your connection point. There's a drainer here. Okay, picture the next slide. Here's what your tank control looks like. This is an air vent. It goes way up on top of the tank. There's a drain here to drain the liquid out of the tank. So if you get one of these tanks and it's waterlogged, what you're gonna do is open your vent, open this, there should be a drain here somewhere. These usually have a drain built into it. The new tank controls are drained in above the water line. So you open the drain, open your vent, and let that water drain out of the tank. When that tank's empty, you're just gonna close your vent, close your drain, open your valve and let the system seek its own level based on fill pressure. Now you've regained your expansion volume. The reason the plain still tanks are bad is I have air here with the water interface. Over time, this water will absorb this air. That air will get it trained in this water over time and it'll just keep filling the tank. If I go back to here, this is why when you have an air separation device with a plain steel tank, I want it connected to this control because whatever air gets into this system gets separated, I send it back to this tank. I'm recovering the air I'm separating out. So even after it gets entrained, it's just going in a circle. It's going back to the tank. But over time, these will waterlog, always. If you get that call, look at your glass.
Because the air dissolves into the water and
Correct.
causes all kinds of corrosion problems too.
Right, exactly. But the big thing is you want to return the air to a plain steel tank. You don't do that with a bladder type tank. And we'll get into that in a second. Everybody follow me on a plain steel tank?
We call them compression tanks.
Compression tank, same thing.
Yeah.
Plain steel compression. And you always want this tank high as you can get it above the air separator so that air will return to the tank.
So on your 130-foot building, your example, you're gonna find that's gonna be up in the penthouse. Right?
Not necessarily. We just want it above the air separators. Wherever your air separator, but typically in a high tall building like that, your mechanical room's typically up on the top floor. Because now instead of me having to do a 250 PSI ASME tank, expensive. If I put all my equipment on the top floor, I only have 12 pounds up there. Now I can use 125 pound ASME. I don't my 12 pounds of tilt pressure because of gravity. If I put 12 pounds on the top floor, by the time it comes all the way to the bottom, it's going to be at 200 PSI. But if I put it, most of the equipment rooms go on the top floor, so you don't have to worry about that too much. But the biggest thing is it's all in equilibrium, but this just needs to be higher than the air separator, so the air can rise into that tank. Doesn't necessarily have to be on the top of the building, it just has to be higher elevation. And if you set that on the floor, the air comes up and it's going to just bottle back up here, it's not going to get back down to the tank. And then you'd be waterlogging constantly. Everybody follow that? Any questions on the tank control? That's just what we call it. Down the glass, I call it something else. But it's just the drain and a connection point for your tank, and it's got that vent built into it, so you can open the vent so it'll leach out and drain. So you don't have to open the gauge glass. But any tank with a regular gauge glass, and you get the plain steel tank. Bladder type tanks do not have that kind of gauge glass.
There's a lot of ones like that too, where they just plug where the gauge glass is supposed to go.
Yeah, I bet they do, but it kind of, but the plain steel, you need that gauge glass, so you can tell if you're taking water.
It's always water.
Exactly.
So something that we do is carry an air compressor
Mhm.
and put it on a drain in that tank instead of having to drain it down and refill it, because sometimes it takes days.
Well, yeah,
So,
help push it out, you mean?
well, no, we'll put the air pressure back on the tank from the drain of the tank. And then just relieve the pressure off the boiler drain that we're building up,
Just to help
just to get that air pressure back.
evacuate the tank, yeah. And again, here's a, whoops, sorry, one button. And again, here's what we were talking about. Here's your tank empty, here's our air cushion, that's your initial water flow. It's gonna fill part of that tank till it equalizes, whatever your fill pressure is. Then you only have this as your expansion volume. So if your tank starts off way high, it's gonna run out of expansion room very quickly.
The other problem is that air admittance line, that little thin little capillary tube,
Yeah,
that's the first thing that always plugs up.
Oh, I'm
Then
sure it
it
does.
takes- Then it takes forever to drain it because
that's, yeah,
it drains a little, then it sucks some air, then it drains a little, sucks some air.
That
If you
never
put a hose on it, it's even worse.
that never had. No, you're absolutely right. Any questions on this so far? Everybody got a good handle on this? Now we're getting into bladder type tank. Same situation, however, I want to pan my bladder tank in below the air separator. And the big thing is, see this little air vent here? When you come out of your system, however you go, on your last 90, before you break to your expansion tank, you want an automatic air vent there. Because in a bladder type tank, and we'll show you this in a minute, water is in the bladder. The air compression is outside of the bladder. I do not want any air in my bladder, because I'm taking up water.
You're taking up
Expansion space.
space, really.
So you always put this here, you put an air vent up here on this one, instead of returning it to the tank, I want it to go to atmosphere. And I want one air vent right at the last 90, so you need two air vents. One on top of the tank and one at that last 90 before you break down into the tank, put an automatic air vent there. Okay? This is talking about, just the benefits of a bladder type tank.
That's a full bladder tank?
Either one, diaphragm, they all work the same. The only difference is that diaphragm does not have a replaceable bladder. They make this acceptance volume tanks. We're going to show you all these in a minute. They're less money, but you can replace the bladder in that in the full bladder tank. So this is just talking about the reason you want to use a bladder tank. They don't waterlog. You have an air charge, and for example, here's a install right here. There's two tanks. Here's your air vent before we come down to the tank. If you can buy one big tank, but if it's can't get it in the building, and some of these tanks will be used for some buildings, they get up to like C8s, 5,000 and 8,000s. They're horrendously expensive. A lot of times it's cheaper to have two smaller tanks price wise, and they can just work in tandem. And plus, if you do lose a tank, you still got some expansion capacity left. But again, we're on the pump suction side. Here's our air vents. There's our tanks. Any questions on that? Here's a reference. This is showing you the difference, because on an air tank, whatever your fill pressure is, I'm starting this tank to that pressure. There's a little Schrader valve in the shoulder. If I have 12 pounds of fill pressure, I want 12 to 13 pounds of air outside of that bladder. Like I said,
You let the water in.
before you let the water, because when you put the water in, there's 12 pounds, that tank's already pressurized, 12, the bladder's flat. Now the water tries to get in the bladder, it meets the equal resistance, it stays empty. Then as I start heating up, the water starts migrating and opening that bladder and compressing that 12 pounds in that tank as the system pressure goes up. System cools down, it's going to collapse and push the water back in the system. So you're just exchanging the water back and forth as the system heats and cools. But you have to have that fill pressure on the tank. So about every year you need to, typically when you pipe these, I have another diagram on this, but this is your Schrader valve. There's a little fitting up here. It looks like a car tire. And you need to check the pressure in this without any water pressure on it. So typically when you put these in, you need a valve here with a drain. Now the inspectors don't like the shut-off ball valves there, but if they quirk about it, you can take the handle off, wire it and hang it, then they're good with it. They just want anybody accidentally shutting that off and losing your tank. So you really want a ball valve, a drain valve tied into your tank here. So once a year, you shut this ball valve off when the system's not firing. You drain the tank down, open the valve to get all the water out of it, because that pressure in here is going to push it out. And take a reading here and make sure your fill pressure, your air pressure is there.
Drain all the water out, isolate it, drain all the water out.
And whatever my fill pressure is, I'm at 35 pounds. Make sure you have 35 pounds of air pressure.
So you don't just walk up to them and press that little Schrader if you hear.
No, because
there's air.
I don't know what my system pressure is on here. I got to get the system pressure off there to read what the true air pressure is here. Follow me?
Yep.
So you need to break it from the system, or you can put a union here and just bust the union, shut the valve up and break the union. And then if there's water in this tank and your pressure is low, when you put a compressor on here and try to charge it up to 35 pounds, but it's only 12 pounds in there, that extra air will collapse that bladder and force the water out of the top of the
I'm
tank.
just a little bit confused, because normally I see where they're connected to the system at the bottom of the tank and then the Schrader's up.
Some are, like my CBX tanks, are bottom connected.
Yeah, like
This is
in all your
actually-
examples, like your drawings,
But
That's what's throwing me off here.
but don't get hung up on that. I just need, whether I'm connected here with the valve or the valve and I'm connected here.
I'm just wondering if it's connected on top, how you drain it.
Well, that's my, no,
Or
no.
when you check your bladder pressure, it's gonna push the air. It's
When
gonna
you,
push
when I
the
put air
water out.
pressure here, if this is open to the atmosphere, as I put air in here, it's gonna collapse that
It's
water and
push
the
it.
air gonna come right out.
Okay.
But the bottom one that should possibly drain out, but again, you still need to compress that bladder because it'll, get a siphon in there and may not drain. And you never, a lot of tanks that, there's always like a plug in the bottom of these. Never, ever, ever take those plugs out because that's the air side. They come in handy when you break a bladder and the tank's full of water. And you've lost your air charge, then you can take that plug out to drain the tank. But the water's in the bladder, so removing this plug at the bottom, you're just letting air out. Because the bladder's here and the air is all down in here. So you can pressurize it, like that, break the union, pressurize it, it'll push the water out. Or pressurize it and it'll come out the bottom, depends on the connection. They work the same way. Are we clear of that? Good with that? What's the question?
Oh,
No, he looks like he had a question, but like I said, this is the equivalent plain steel tank. In my bladder type tank, just because this has 20 pounds of fill pressure on it. Here I'm starting with atmosphere. So I have to have a hell of a lot bigger tank to take up for that first compression. So they're much smaller to go to a bladder type tank. Everybody understand that? And again, here's how that tank works. Here it's talking about the air on the outside, expanded water fills the bladder, and the air just keeps pressing the water back and forth as it heats and cools. Everybody follow that with the bladder, whether it's a diaphragm, partial bladder, full bladder. They all have air on the outside, one side of the bladder, and water on the other side. Wherever the Schrader that's connected to the air side, the water side is connected inside the bladder or on the other side of the diaphragm. If you ever open a Schrader valve and depress it and get water out, guess what that means?
That's bladder.
What's that?
Got a bad
You
bladder.
got a bad bladder. You might get a little bit of water, could be some condensation. I'm talking you open it and it shoots water at you. You know the bladder is bad, and you'll get that same call like we did with the plain steel. Hey, I'm lifting relief valve. What the hell is the problem? First thing you want to do is open that Schrader, press it. Oh, spit out water. I know when I'm lifting my relief valves at home. I've lost my air charge. I have nothing to expand again. That tank's just a big piece of pipe now. So I've lost that air on the other side of the bladder. Ready for all that? This is a picture of a diaphragm tank. You see, this is actually just like a diaphragm in your body. That diaphragm gets put in the middle of this tank, but you cannot service that diaphragm. The water goes, the air charge goes on one side, the water goes on top, and it just expands this bladder back and forth against that air charge. So if this rips, there's no replacing it. It's a throwaway. You just have to throw it away and get a new tank. There's no way to service the diaphragm. That's true with Bellingossett, Amtrol, Keiko, anybody. Their diaphragm tank, just make sure you look, it'll say diaphragm, but it'll tell you it's got a replaceable bladder. This is what the inside of a partial expansion diaphragm looks like. This might be 45-gallon tank and this bladder may only hold 15 gallons. But again, this bladder inside the tank has to be big enough to take your expanded water volume, which you can calculate. So if you calculate your system, once you do the calc, it'll say, I've got 12 gallons of expanded water, but I need a 34-gallon tank. You go to the partial bladder expansion tanks. Okay, this tank's got a 15-gallon acceptance with a 34-gallon for air. I can use that tank. If I have 12 gallons in here and I need 20 gallons of acceptance with a 34-gallon tank, go to the next bigger tank. My expanded water volume has to fit in the bladder. Okay? That's all the water will take. And the rest is all for that air cushion. That's why it's a 34-gallon tank with a 12-gallon. As it expands, I'm only going to make 12 gallons more area. When I hit 200, I'm not going to overextend that bladder. Some of these bladders are hung with a hose. And if you get them over expanded, they'll pop off the hose and drop the bladder off. But these are replaceable. You can lift the lid, you can put a new hose and bladder in it. Compared to the diaphragm, it's a throwaway. This is now here's where we're talking about the full bladder. This is the connection that goes on top here. This bladder lines that whole tank. See how big that bladder is? This is 100% acceptance volume tank. This is partial acceptance because it's not as big as the tank. This one I can fill.
You said 100%, there's other things.
If I have a 100-gallon tank, I can put 100 gallons of water in this.
So where's the air go?
Well, you don't want that. I'm just saying, you don't, you have 100% acceptance.
Calculations.
When you do the calc, it'll say, I'm only having 30 gallons of acceptance, I need a 100-gallon tank. But in this case, if you lose all your air charge and I fill this tank all the way up with water, I'm not gonna break my bladder. Or with one of these, I can break the bladder. The tank's 34 gallons, the bladder can only hold 15. If I fill that bladder up to 25, it's gonna run through the bladder. There's nothing to
The
hold.
balloon will pop,
Right, the balloon will pop.
the balloon full of water.
Where this, I'm gonna expand out to the wall of the tank and it's not gonna hurt. These are all made of heavy butyl rubber. These are kind of a pain to do, but you can collapse this and pull it out through here. The best way I found to do them is take all the air pressure off, get the water out of them. Open this, and this neck actually is your gasket. This flange sits upright and sits on here, and that top cover actually sandwiches that as your gasket. So once you take that top cover off, you can get around this with like a choker, lay it on its side, put it on a chain pull, chain the tank down and just pull it out. Then once you get the new bladder, you unroll it, powder it, you kind of roll it up in a ball and work it down in with the stick.
Powder.
Well, you want to put some talcum because it's slippery. You put a little talcum powder on the outside. You want to lay it on for make sure it's totally clean so you don't get any garbage on the bladder. And then you just roll it up, push it down in the hole. You might use a stick to help it go down there. The talc on the outside gets a little slickness to it to go down that. But the opening's only this big. And then once you get it in there, close it as much as you can and shoot air into the inside of the tank, which is the water side, without the lid on it, just to try to unfurl that bladder, get some air pressure. What's that? To open the bag up, right? Then once you do that,
It gets it situated in there, so.
right, you're just using air on the inside. I don't have the lid on yet. And then once I put the lid back on, then I go to the Schrader valve, charge the outside of the bladder to what I'm supposed to have. Okay? Everybody follow that? Here's another look. Here's another bladder tank. You can see how small that neck is. This bladder has to go into that tank. Here's some of those plugs on the sides. Like this plug, the only time you remove that is if that bladder breaks, you can open this to drain the water. Otherwise, you don't want to open. There's plugs on the side. I have seen people like put nitrogen charges on these because the outside is full of air. So they'll take a nitrogen bottle and reduce it to whatever your fill pressure is, 30 pounds, and hook it into that side connection and keep. So if it loses any air, the nitrogen bottle is just going to keep making enough to never run out of air. So the nitrogen bottle is exhausted.
Do they last longer because you're not putting oxygen in contact with that rubber?
It just helps corrosion, et cetera, with nitrogen. You know, that's why you fill air boilers up with nitrogen, helps reduce corrosion. But the big thing, they just use nitrogen because it's not, you know, if you're using oxygen, that's very bad. You know, it can go boom, you know, where nitrogen is inert.
Well, also most of the oxygen that we have, or most of the air that we have, compressed.
I think compressed air has a lot of
Has
moisture in it.
traces of oil in it.
Right,
That's the
oil and
reason why you
moisture.
can't use it for scuba.
And you don't want to use it for bladders either because oil and butyl don't play well together. So that's why they use nitrogen. But then it's a dry layout, you know, it's no moisture, no oil, no nothing. But you can see that bladder will go into that tank. Like I said, the diaphragm and these, you can pull this bladder out and replace it. The only problem is, let's say this is a $3,000 tank. That bladder is about $2,200 of it. So a lot of times people will say, you know what,
Replace the tank.
2 days later to change that or $800, I'll just replace the whole tank. So that's why a lot of the smaller diaphragm tanks make sense because you just throw them away anyhow. You're not trying to wrestle this big bladder. The diaphragm tanks are a little easier because the bladders are much smaller, but these are kind of, this is going to be a work chore to get that in and out. Any questions? Again, we were talking about when you cross-reference a tank, a lot of people say, I need a 40-gallon expansion tank. If you go to a partial bladder expansion tank, you can take a 60-gallon full acceptance. You can't put in a partial acceptance tank there because you don't know what your expanded volume is. It never errs. You can't err on the side of safety by using the full acceptance tank because you don't have to worry about how much water that bladder can take. So you've got to look at the tank and see what the acceptance and what the total volume of the tank you have in the field. Let's say you find one that's bad. Keiko, Bell and Gossett, they all pull up one of the submittals. It'll say acceptance volume 12, full volume 34. Your new tank has to have at least that acceptance volume and at least that full volume to work correctly. Or if you had a 34-gallon tank, just went to the full acceptance and got a 34-gallon tank, that'd be okay as long as you go to the full acceptance, not from a full acceptance down to a diaphragm. Everybody follow that? And swings in pressure are dictated by the relative size of the expanded volume. That's why you have to be careful how big my acceptance is in my volume. I have to have enough volume to compress to work correctly. If I'm short air charge, I'm going to lift the relief valve. I have to have enough room to compress and make that look right. So just expanded volume, like I said, 5-gallon. This is your bladder. This is your whole tank. This is a full bladder. You know, you've got to know what both those are. Kind of reiterated it. Now here's getting into sizing tanks. And basically what this says is your volume 1 and your volume 2, the little V's here are actually your specific, how much your liquid expands at first temperature and high temperature. So typically when a tank, we use 40 degrees fill pressure. That's usually what your cold water is. On a heating system, we'll size it up to 200 degrees Fahrenheit. So this is the specific gravity of water at the density of water at 40 degrees and the density of water at 200 degrees. -1 times 3 times alpha. This is your expansion coefficient. Remember you were talking about glycol? That with that linear coefficient of expansion, that's going to change whether it's water or glycol. You have to look up at a book at 30% glycol, 50%. It changes all the time.
Does the glycol expand more or less than straight water?
A tank gets bigger. Glycol
Expand
works on heat transfer.
So your acceptance volume is going to go up.
Correct.
Glycol.
Right. So you put those in there. Your delta to your system, like I said, we use 40 to 200, so that's 160 degrees goes there. My pressure 1 over pressure 2 minus my pressure 2 over my pressure 1. And when you calculate that, that'll give you your expanded volume. Now, the best thing to do with this, here's an example of one, but instead of doing all, we make this nice little program. Go to your computer, go to Takeo Comfort, go to Bell and Gossett, go to just about any John Woods, Wessels. They all have something similar to this online. And all you have to do then, again, tell if it's copper or steel, put in your system volume in gallons. This is what's my fill temperature? 40. What's my max temperature on a boiler system? 200. Fill pressure, anything less than 25 feet, you're going to use 12 pounds of fill. And then this pressure here is 5 pounds below your relief valve setting. If I have 125, that's 120. If I have 75 pounds, put in 70. You can mark this for standard NSF certified stainless steel, anchor clip, sight guard, hit send, enter, and voila. It tells you I can use, this is a CA tank. This is a full expansion tank. That tank is 37 gallons of acceptance with 37 gallons of only the CBX 254. This is a diaphragm tank. It's a 34-gallon, 67-gallon tank with 34 gallons of acceptance. Okay. The CX, this is my diaphragm tank. Again, I have my acceptance and my full volume. Here's my P access for domestic water. And this is your plain steel tank, has to go to an 80-gallon instead of a 37-gallon tank. Okay? So instead of worrying about all these formulas and looking up coefficients, blah, 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 you can even come in here and tell that I want water, I want 30% propylene, I want 30% ethylene, I want whatever. This will spit out and calculate your tank volume, your expanded volume, and then when you do this down here, if you look, it says right here, specific volume of the fluid, 0.016 cubic foot per pound, specific volume is here. And it says calculated system volume 28.3. That tells you right there how much I've expanded my water. But the program will select all this for you. Like I said, you can go to Wessel's, John Woods, everybody's got a side equipment, and they're all this simple to use. So don't worry about pulling up all those equations I just went through. Go to any of those sites and you can just do this yourself.
So unknown on a job, hidden piping, how do we guesstimate our capacity, our water volume?
It depends on the pipe size. But the biggest thing, you're talking heating.
Yes.
And a heating system, again, whatever your BTU input is, divide by 55,000, or divide by 15,000 and multiply it times a 5.5. Use that number to use your CA type, which is a full bladder acceptance tank. Use that number you get. So,
Full acceptance,
huh?
full acceptance.
Yeah, somebody's got a calculator. Do like a 1 million BTUs divided by 15,000.
It's 6.6,
Times 0.55.
36.6.
36. And I go up to my take-home book and I go, wow, here's a CA full bladder tank. It's 37 gallons. Could you use that for his? Until it needs 36, that's 37. Will that work?
Yeah.
There you go. There's your tank.
And it doesn't matter how actual total volume of the system or.
This is so forgiving. I've used this for 34 years and I've never had it be wrong yet. There's fudge. There's a lot of fudge in here. Right. But if you go above like 20, 25 pounds of fill pressure, call us, because it gets different. But just at your average 2-3 story building, you can use that equation all day long.
Because your fill pressure is actually doing some compression on the water.
Right, because the higher I go, the more I'm starting with, the more air charge I need, the bigger the tank is. But this is calculated, that rule of thumb using about 12 to 20 pounds of fill pressure. It'll cover it. And it's so fat that you'll never have an issue. We've never had a problem with it. But just remember, input, not output, your input. Yeah, not if the boiler's 1 million BTUs and only outputs 880, use 880. That's all the heat I can generate. Divided by 15,000 times 5.5. Take that volume, go look for a CA tank. Bell and Gossett has theirs would be I think it's the B. And you can just look up their tanks. They'll say full volume, partial volume, the full volume bladder tank. You need 35 gallons and they make a 38. That will never fail you. 34 years, I've never had one be too short. Ever. And we do it a lot. So, yes, sir.
So have you ever had to get the length of all the pipe and the size of the pipe to?
But that's ideally what you want to do with this program. See right here, they ask you for your system volume right here. That's where you would enter that number. You say, okay, you got the diameter of the pipe times, the radius squared times pi times the length of the pipe gives me a volume times 7.45 gallons per cubic feet. And you do that for every pipe size. I come up with 800 gallons. I stick that 800 here.
Yeah.
Put in my temperature. Boom. It's
So
gonna give your tank.
length times the size of the pipe. Yeah.
Right, just the volume. You're gonna come up with a system volume in gallons and put it into this program. But if you don't know that and you know what the BTUs of your boiler, you can use the rule of thumb, and we've never had it air yet. Because it's a fat number. You could probably get away with a 25 gallon, but when you're guessing, I don't want to buy 2 of them. Any questions on that? So it's a good rule of thumb to know, and it really does work. But make sure you do the full volume tank. You don't want a Bellinghausen D or a Takeo CBX tank or a Takeo CX tank. Those are the diaphragm and partial bladder. They won't work because you don't know what your expanded volume is. But the CAs or Bellinghausen Bs, you know, and I've got some charts here in a second. You'll see I've got everybody's tank models here for you. And again, here's our selection. Again, we talked about the, you know, here's the full volume acceptance. You know, it says 3737. You can tell this is a partial 3467. But my expanded volume has to be less than this number for that to work. And then here's the CX, which is the same 42 and 79, but this is the diaphragm throwaway tank. This is a replaceable bladder. They're all ASME.
So the diaphragms and the partials, you run the risk if you put too much in there.
You can blow the bladder or break the diaphragm. But if I go with this one, but the problem is, this is cheaper, this is next, this is more expensive. Of course. Yeah, so that's a bigger bladder. That's a much bigger bladder, more money in the bladder. And then this PAX, anytime you see the PAX, I'm gonna get into that in a minute. That's a domestic, and then plain steel is, or compression tank is 80 gallons. Yes, sir.
Rough guess, how long do bladders last? Anywhere from,
You know, I've got bladders out there been out there for 20 years. I got some that go out there, they're gone in 5 and 6. There's no real rule of thumb. The bladders today are very heavy butyl rubber. And especially in the 15 years ago, for booster systems, when we had to use a NSF tank, the Food and Drug FDA would not allow us to use butyl for food. And we had these polyvinyl chloride bladders that were just horrendous. If you got 2 years out of it, you were doing good. They were very thin. The material was very brittle because it was polyvinyl chloride, but that's all FDA would allow us to use. So we were selling bladders on the booster system about every 2 years, planning on getting a new bladder. 10 years ago, FDA said, butyl's good. Now the bladders, instead of being paper thin or half-inch thick, and they'll last 20 years without failing. You know, there's no rhyme or reason to it. We sell bladders, we don't sell that many. You'd be surprised at how many. I probably sell hundreds of tanks a year, and I might sell 30 bladders a year, if that. For the last 30 years, I mean, they just don't.
That's about how many people want to try it once.
Well, or they just don't go that often. You know, in replacement tanks, it's, you know, they can last 20, 30 years because they're not exposed to sunlight. And it all depends on what's in their water, how corrosive their water is, because they wind up with something in that's not detrimental to the butyl, some oil. Your bladder's going to fail.
so if the bladder's 35 years old, it's still gonna borrow time.
I mean, it's like anything, they expand and contract their whole life. So the more you work them, it's like, you know, you work a balloon so long, they fatigue, you know, anything fatigues. But,
You might run the risk with a condom.
what's that?
If it was a condom, would you use it?
That's why you only use those once. But anyhow, there's no rhyme or reason, but if you get a big system that stays hot, like in a
But
hospital.
if you pipe it right, it's not that hard to check it. You're
Well, it's
heating
just
start up, you drain it, isolate it, drain it.
That's down twice a year and stays at 200 degrees all year. It's not expanding and contracting all the time. It only recontracts when it gets cold. But if they keep that boiler on in that hospital,
Oh, it was-
365, that bladder expands once and stays there. It's not doing this all the time, but in a house, you know, every summer, winter, you know, the boiler breaks down. Every time it gets cycled, it's expanding and contracting. So make sure you check those air charges once a year. Get the water pressure off, check that air charge and make sure it's equal to the fill pressure plus a pound or two. That's very important. Okay. Here's the charts I was telling you about. Here's Amtrol, Bellinghausen, Wheatley, Wood, Takeo. These are all partial expansion tanks. See, they all have two numbers, 11, 2.5 and 11, 2.5, 5 and 12. If you go out in the field and say, hey, I found an Amtrol AX60. Well, I can call the Takeo guy. He's a really nice guy. See if he has the CX130 in stock. Or call Bellinghausen. Tom has these.
Yep, I can put them on a PDF and put it
I just
on
looked at
Facebook.
that, that's actually an app you can put on your mobile phone. And it's got heat exchangers, all kinds of.
Okay, so this is something Takeo came up with. And just a cross reference to all the major players. So if you find a partial tank, There's the full acceptance tanks. There's 2 pages to these because it gets so big. But again, I have a tank of CA 250, and it's 57 gallons of acceptance, 57 gallon volume. If I go to Bell and Gossett, it's a B200. But full acceptance, look at that full acceptance and partial, or like the CBX is the diaphragms, they're just cheaper. But any acceptance tank, for example, let's say I have a CX 130. I can go to a CBX 130. It's got the exact same expansion volume, it's got the same tank volume. The only difference is the CX is non-replaceable. The CBX is a replaceable bladder. That model is the same whether it's CX or CBX. B just means it's a replaceable bladder. Same tank, just one has a replaceable bladder, one doesn't. The CX will be cheap. Just a throwaway tank. Any questions? Making sense? Get into plumbing. 5-8 years ago, they came up with NS 372 and NS 61, NSF 61. This is all the lead, low lead. This is really important in the city of Cleveland. Just ignore all those lead pipes down in downtown Cleveland. Those have nothing to do with the lead in the water, but we got to make sure our stuff is lead free. So, okay. Notice that's tongue in cheek. And they just said this is just a way to make sure there's no contaminants in the drinking water. NSF 61 and 72 are very similar. NSF 372 basically says I'm allowed 0.25% lead. Some jurisdictions will recognize NSF 372. Other jurisdictions want NSF 61, which is much more stringent. And this will just tell you if you want to read through there. It just tells you it applies to drinking water and for human consumption. And it all comes down to one thing: low lead. And that's why they're trying to replace all the lead pipes in a lot of these cities. But the problem with this is the prices all went through the roof. You know, because everything is now zero lead. Certain bronzes can't be used anymore. You know, everything went to stainless, and now stainless is actually cheaper than a lot of the bronze. NSF 61, again, it's another safety standard. And this basically says no lead. They don't allow any lead at all. Much more stringent. These are our PAX type tanks. The PAX, they look just like the CBX tank. They're identical. They same acceptance volumes. The only difference is my normal expansion tank is normally 125 pound ASME. For plumbing, these are standard at 150 PSI ASME. That's the plumbing code. They want 150 pound pressure. And again, you would size these the same way, except I'm going to have 40 PSI of inlet water typically. Whatever the building makeup water pressure is from the boosters, that's what you want to size that. So we always use 40 PSI, go to 145 because all the water systems have 150 pound reliefs. And you put in your volume just the same way you would, except
As you designed it for 145.
exactly 140, you know, 40 to 140, 140, 40 to 120, whatever your system is. And your relief valve would be 40 PSI to 120 or 145 to this 150 pound. And it'll make this PAX selection for you. And the only other difference is it has the same bladder in it, 150 PSI, but if you note on the top of these, this whole head is stainless. And this is stainless because these are for domestic hot water. Domestic hot water is horribly corrosive. If you hook up a plain steel tank, a standard CBX or CA tank that has a steel connection on a domestic system, that connection will rot away in about 3 years. The difference is in a hydraulic system, I have an air separator. I remove the air, so the water is not as corrosive. When I have entrapped air in here, and it's in a hot domestic system, it's horribly corrosive. 2 years ago, I put some fin tube in my old house's living room. I couldn't find any brass nipples. Well, I put steel nipples in. No, that's 10, 20 years. It didn't last a year. They were all just,
They
crumbled in
became
my
the
fingers.
sacrificial lamb.
But yeah, they just ate themselves. And that's why the PAX.
We've seen that before.
Oh, absolutely. Absolutely. But I'm just saying, you don't think it, but domestic hot water is horribly corrosive. So these all have a stainless steel lid. If that's the difference between the potable, with that stainless steel lid and the 150 PSI design.
And they're not finished.
What's that?
That's another reason why it's so horribly corrosive.
Well, it's open loop, you're getting oxygenated water in there and it's hot, it's corrosive. Here's the PDX, remember I talked about this NSF? We make this tank, that PAX 30, I can give it to you in NSF 61 certified. Or I can give you that tank in non-certified. And it all depends on how sharp your inspector is. Technically, they need to be NSF 61 certified. Same tank, same materials. The only difference is NSF, like ASME, carries paperwork from birth to death. And they can go back and look up this tank and they say, okay, this seal came from such and such. It was certified lead free by this guy. And you know, every step of the track for proving that it's not containing any lead. And when you have that NSF 61 certification, you guarantee it's no lead. The exact same tank comes off the line. It's not lead, it has no lead either. The only difference is I don't have a piece of paper to go with it. So, you know, you can use the standard ones. We stock all NSF now, just airing on the side. But there's a lot of people out there that put the regular one in, and a lot of the inspectors don't even pay attention to it. But I mean, it's still lead free. You're not endangering your customer. You have a piece of paper. Any questions on that? A lot of times you're going to see, be careful when you look at products. A lot of people, the new tag word is NSF 372 compliant. I'm NSF 61 compliant. The difference between my two tanks here, my standard PAX 30 is NSF 61 compliant. My one with the certification is NSF 61 certified. So somebody tells you, you know, you say, is this so lead? Oh, it's compliant. You're taking a gamble. You don't have the paperwork. They're telling you all the material was built in accordance with NSF 61, but they didn't pay an inspector to watch you build it. They don't have a paper trail for it. So it gets kind of dicey, you know. It's the same pump, same heat exchanger, same tank.
Third party, that means somebody actually stands there and watches them do it, or
Absolutely.
they're just allowed to visit your plant at any random time.
They hire them, they work for whoever, and they're a certified inspector. And their signature goes on everything that goes out the door. Same with ASME. And you have to have the NSF. This certification comes like up here in Cleveland, they have what is it, CSD, the Canadian standard, or ANSI, or ASME. They all have
CS
codes and they have inspectors. And NSF, you have to send your tanks to in Cleveland. And they do their independent test, and then they send you back a piece of paper, recertify this thing has no lead in it. They'll tear it apart and search for lead, and then you gotta pass their test. And once you get that certification, that inspector watches everything, and they keep track of the steel that comes in, it's all sampled for no lead. Everything goes in that tank is checked and paperwork to follow. But the other tanks use the same material, there's just no paper trail saying somebody certified it or watched every material. You know, it's compliant because we used all the same material, it just doesn't have the paperwork. And the paperwork's, you know, a difference between say a PX 30 non-certified is 1,500, the certified is 2,000. Just for that piece of paper.
Since you're in NIST, you can buy an electric test meter.
Yeah,
You know, you want that.
that's right. What that stamp on it.
Comes with it.
Or UL or
Yeah.
ETL, whatever, those are all third-party testing.
Or subsafe, same way in Navy.
What's that?
Subsafe has that, anything that's in contact with a home.
Exactly,
They have this paperwork, they can go all the way back, they can tell you what mine that ore was.
right. Exact same with this.
Yeah.
They'll tell you where this metal came from, its assay, everything, you know. It's but you're paying for that. It's a significant price. And it costs the manufacturers a lot of money just to get certified. And they gotta send 50 tanks to these guys and they'll cut them apart and blow them up and destroy them to get the certification. It's like FM, Fire Mutual. You know, they send them 20 pumps and they blow every one of them up to say, okay, you're good. You know, that's a lot of money. Shipping, materials, time. You know, so.
Destructive testing.
Exactly. Anybody have any questions on that? No? How much are we doing on time?
If you wanna keep going, keep going.
Okay, we good?
Yep.
All right, I also advanced and I brought some more stuff in, but you can only say so much on expansion tanks about covering everything I can think of. Thanks. Is there any questions on expansion tanks? Any doubt in anybody's mind?
It's a Taco flow through expansion tanks. What's the purpose of those?
Oh, we do have, I should have brought it up. That's a good point. I should have put that in my presentation. That's something fairly new. Taco just started building these flow through expansion tanks, and the idea is the big problem with domestic nowadays is Legionella. If you get stagnant 100, and if you keep your water above 130, you're good. Legionella can't live over like 130, 140 degrees. Anything below 70 degrees, Legionella can't live. However, domestic water that runs 110, 100, 110, 120 degrees, perfect spot for Legionella.
Plus your expansion tank, that's a dead leg of stagnant.
Well, that's exactly what the flow throughs do. Instead of that water just sitting captive in there and not moving and develop a Legionella, these new flow throughs actually bring water in and it circulates that tank the entire time it's expanding and contracting.
How did we even survive drinking from the hose?
Exactly. But good, I'm glad you brought that up. I did not think to put that in my presentation. I will next time. But that's exactly, if you look on Taco's website, there's called flow through. They have just a different head connection. It's like a T connection on top. It still allows it to expand and contract, but it allows water to circulate in that tank. As the water moves in and out, it's actually turning that tank over every time. So it's a flow through tank. It's not stagnant. And it gets the water moving so it won't develop Legionella. That's the whole idea behind it. Very astute. You get a gold star. Yes, sir.
Hospital 200 degrees all the time, is that still have the same flow through?
Well, that's only for domestic.
Oh,
We don't worry about Legionella. Nobody's drinking the heating water. It's only for domestic.
okay.
When you're ingesting it, and it's not, Legionella isn't that dangerous to ingest. The problem is, like where Legionella first came from, and that one cruise ship when they finally had it, developed Legionella bacteria in the cooling towers, and it goes airborne, and it was getting sucked into the air duct. As people breathe it, and then they get respiratory issues from Legionella. Same thing, you're taking a shower, if your tank's contaminated with Legionella, that water blowing through your head, it's going airborne.
It's growing in the head.
Well, no, but I'm talking to your expansion tank or in your
Yeah.
domestic system. That Legionella bacteria comes out of your shower head and goes airborne. Some of it vaporizes and you breathe that in, now you can contract. That's why the big thing on domestic is.
So well, since we got on this subject, so Legionella, so above 130, 140, it should.
You can't survive,
So the higher the temperature, the better
right?
when it comes to fighting Legionella.
What's that?
When it comes to protecting yourself against Legionella. But the other problem with domestic hot water systems is you start getting over 160, 165.
It's called,
You're gonna,
it's
you're
called
gonna,
hazard.
well, you could have mixing valves down the line that
Right.
protect you from that. The problem is in your tank. Every bit of minerals and everything are gonna precipitate. You start getting real high temperatures like that, it precipitates all that out. You can take a tank and fill it with sand in a really short period of time. You start running up like 180, 190 degrees. So that's what they were trying to do to compensate for volume at these dialysis centers that I worked at. And I've opened up little handholds, and by the time we were done, we had 4 inches of sand in the whole equipment room.
Now, one thing, the reason Legionella has made its appearance in domestic is of all the use of the CPVC, PVC, and Worsbo and Viega plastic tubing. Copper kills Legionella. So 30 years ago, when every damn system in the world was full of copper, Legionella couldn't exist in the piping systems. Now the new, huh?
Copper with lead solder.
Yeah, well, you know, I take the good with that. But the point was the copper. Legionella with copper, the ions of the copper, Legionella cannot survive.
Right,
copper.
right.
But now these systems are all plastic, and 120 degrees, you get that bacteria in there. It's just a breeding ground for it. That's why we designed the flow through tanks, so we don't wind up with a domestic tank of static water. You know, constantly mixing it out of there.
Only you can sit with water from a moving stream,
What's it exactly?
not stagnant.
Where did you see the flow through tank?
AHR Expo.
Oh, you went to
I
the,
was last year when they first came out and I saw them.
Okay.
This year.
yeah, they just came out with them last year, that was the new products for us. They're not selling a lot of them as long as people aren't panicking over Legionella. But
He's conscious of the new stuff.
yeah,
Somebody else tested out for a while.
I'm impressed you picked that up. Very good. Next, I should have put it in my presentation. I should really didn't think about it. It was fairly new for us too. We still good on time?
You guys wanna keep going, we'll keep going.
Everybody board shitless or? I don't have a lot left.
Nobody wants to be the first guy and say, okay, that's enough.
Keep going.
This decouplers, does everybody know what a decoupler is for? In chillers and boiler systems, this is a decoupler. The idea behind this is when I connect two pumps on a chiller over here, and I connect my heating system on this side. The beauty of these decouplers is this system and these pumps does its own loop this way. This system does its own loop this way. They meet in the middle here and intermix. The beauty of this is, let's say I'm running 10 degrees over here and I want to run 15 degrees on my chillers. Well, if I'm running 15 degrees in my chiller, as delta T goes up, flow goes down. I might have 100 GPM over here and only 50 here. So what the decoupler allows me to do is my 15 GPM comes in here, and I've got the water flows across these directly. Just treat it like a piece of pipe. Flow here and here's equal to flow this way and this way. But if this is flowing 50 GPM, this is flowing 100, what will happen is this will bypass, this will take the 50 here, this will bring 100 in here, 50 up through here, and I'll still put out 100 here. It's additive. Right. So follow what I'm saying? If I only have 50 over here, I come in here with 100, 50 goes this way, 50 goes that way, 50 comes back in here, I still got 100 going here. I can run two different flow rates without distracting from the other side.
Kind of like a buffer tank.
Well, buffer tank's a little different. I'm gonna go into those in a second. A buffer tank's just for volume, keep chillers online.
It's a decoupling T, basically.
What's that?
Decoupler, basically.
Yeah, this is a decoupler.
Yeah.
And this is real important, especially in a heating system. A lot of times we'll run 20-degree delta T here and 30 or 40 on our boilers. But if my delta T goes up, my flow goes by half. So again, if I have 100 GPM come in here, and I only need 50 here, 50 will bypass up through here from this side. 50 comes back in here, I still got 100 going here. But if you ever want to pipe one of these, just treat this as a straight piece of pipe. It doesn't flow in here and flow out there, no crossing. I come in over here, I go out over there, I come in over here, and I go out over there.
Can you back up to the cutaway that you have?
Yes, sir.
Like that?
We make two different kinds. This is the standard. And they both work as air separators. Here's your air vent. So if you have an air separator and you want to decouple your system, this will take the place of your air separator. This is just for decoupling only. If I put these Paul rings in here, now I've turned it into an air and dirt separator. My dirt collects, I can drain it out here, I can flush it. Micro bubble air collection plus dirt separation. And again, I come in here, I go out there, come in here, go out there. And then the system will do what it wants to balance itself based on that decoupling.
What's the sizes that you
what?
have? What kind of sizes do you have on that?
I go up to 14-inch or 12 or 14-inch on those,
On the low end?
and down to 3/4.
You get them with magnetic.
Yes. In fact, I sold one of these that Hudson Presbyterian Church. The new Tacos are really slick too. It looks like a handle.
So if they're magnetic, can you take them apart and do that?
That's what I'm saying. That's what I'm explaining. They come with the handles right here. It looks like a butterfly handle. Magnet's on. I want the magnet off. I turn the handle, I flush it, turn the magnet on. Put the magnet back on, starts collecting again.
Just it's not a permanent magnet.
Well, it is, but it's how they can turn it off and on by that handle. You just turn it on the side and it really does work. We have I never thought about that. I have a display. Well, it's not here right now. They've done it somebody, but we have a display and you can just see when you turn that handle, the stuff just falls off. Turn the handle back, it sucks right back to the bottom.
Oh, the handle went on.
It's pretty close to
Well,
that.
I saw it.
So you can get those.
Balls, whatever. Holds balls there, and it's certain thing that all ball on.
Oh, that's it. That's what I'm talking about. The ball bearing, it's something right up on there.
So,
Oh, you saw that at the HRA?
yeah, they,
And we have one of the big, they let it out, some I haven't seen it in about a month or so, but it's actually ball bearings, and as soon as you turn it on, man, they stuck right up and turn it off.
second page. Orlando.
Was it in Chicago?
Yeah.
But again, your decoupler does not, you still need your expansion tank. You know, but this could take the place of your air separator. Here's where the flows that I was talking about, here's equal flows, up. Here's unmixed flow, that come in here, it half goes this way, that goes that way, it all comes out, it's all additive. And again, I go here, this comes in here, goes back around, it just, you know, it can go either way. Flows higher here or go that way, if it flows higher here or go that way, you know, it's always additive in there. It's self-balancing. You were talking about, we also make these now. These are just magnetic Hertz separators. These aren't quite the same as the handle ones, but a lot of the new ECM pumps have built-in permanent magnets. We've been finding that the magnets get built up with crap inside and around the ECM. So we made these magnetic separators now. And they're in there.
Even any of the cartridge pumps on these old black iron systems, it's kind of that idea.
Right.
Put something in there to get that, because
But the ECMs have all that permanent magnet and it sucks it all out. And then we make buffer tanks. And we also make buffer tanks with the 4 connections. What's that look like? My decoupler. You can actually use a buffer tank and actually make it into your decoupler and your boiler. And the idea behind a buffer tank is chiller systems today. Chillers come on, they run for 5 to 7 minutes regardless. Boilers come on, they run 5 to 7 minutes regardless. The problem is if I decouple a small boiler loop here, that boiler might be running 100 GPM. So 5 minutes, I need 500 gallons of water to go through that. My piping might only have 100 gallons of water. So I stick in a flow through buffer tank of 400 gallons, or I put one of these in for my decoupler of 400 gallons. So what happens is if this system's no demand, once I start circulating the boiler, I have 400, 500 gallons of water I have to heat before it satisfies. I can keep that boiler or chiller on long enough so it doesn't go off on high head. And because if it can't get rid of the heat, it'll go off on high head. The boiler will trip on high limit. If I only have 50 gallons here, I can add volume here or here by a buffer tank to stick it in the line. And when I'm going around and around my decoupled side, that volume to keep the system online to satisfy the chiller of the boiler. Everybody understand that? If you ever get out of the system, you man, my boiler's off on, off on, off on, off on. You don't have enough volume. Put it in a buffer tank.
What's nice about those is you got eliminates your like your closest space T's, your primary, secondary. Not on those.
But that's a decoupler.
On the decoupler, yeah.
Right, well, the rule of thumb on the decoupler I use is 5, you don't want any more than 5 and 8, okay. No less than 5, if they're too close, it'll recirculate. Anything over 8 to 10, you start developing a differential, they'll pump each other. You keep in that rule of thumb, the loops don't see each other. And again, this fixes that distance for you based on pipe size. When you buy my decoupler or this, it already did that for you. But, or you can use 15.
Based on the length of it.
Mhm. That's how they base this distance. Is that 5 to 8 or 5 to 10? On that or the buffer tank that you cut. There's some tricks, you know, and the back and these buffer tanks, this doesn't flow straight through. There's actually a big baffle that separates it into 2 pieces. So when your water comes in, it has to mix. It's not just a tank, it's got a
Coast.
baffle in there. Got a big steel baffle. Water comes in, it has to go up, it has to turn that tank over. It's not just an empty tank. Now, this is just an empty tank, so it can flow from down. But this, the buffer tank has a baffle.
You make an extra tall one with a bladder on the top of it.
What's that? Well, there you go.
Combine them all. It's like your TV and your VCR in one wheel.
One thing I wanted to mention, all the new Taco pumps, heat exchangers, expansion tanks, air separators, you'll see this little green chip. It's on all of them. That's not a shipping chip. On the pumps, it's right here. There's usually one on the tag and one stuck somewhere on the pump. The expansion tanks, I have them stuck right to the front. The air separator, I have them stuck. This is called near field communication, NSC. You go online and download NSC app. And there's a bunch of them. They're free. You get the NSC app if you have an iPhone 8 or better or any Android. You bring up this NSC app, you start it, You lay the head of your phone right on that green chip, it'll go bing. And it'll pull up everything you wanna know about that product. It'll come up with a page, it'll give you when it was shipped. It'll send you to us, it'll give you O and Ms, part sheets. Everything, right from touching that green chip.
I thought that was an extra plastic chip for like shim and stuff, right?
Well, you could use it for that too, because they peel right off, so. But I just want you to know, if you ever see that in the field. No, I skipped over there, so for this accident.
You link your phone to that though, you're saying getting phone calls about extended warranties.
But anyhow, I've lost my place now. No, I got it all screwed up, but I was the last slide.
extended warranties.
But everybody understands, if you see that green chip, don't peel it off, that's what it's there for. And what's nice is 20 years from now, when you can't read that nameplate, that the information is embedded in that chip, your phone actually activates that chip. The power from your phone brings it alive. And it'll take you right to the website, you can find everything up there. Color cuts, horsepower, everything. ASME, whatever.
Thanks for your time, John.
Well, I'm happy.
Appreciate it.
Ready to learn.
I got a question for you.
What's that?
This in here is a year old and it defaults it off.